Now we are going to balance the ionic equations, and for that we have two methods. One is the oxidation number method and second is the ion electron method. We will be taking ion electron method afterwards. So now we are starting with the first method, that is the oxidation number method. So what you need to do is, I will just recall the points and then I will just use these points in a given question so that you will be well familiar that how we are going to balance it on the basis of oxidation number method. So first thing is that write the skeleton equation indicating reactants and the product. Like you should have a skeleton equation, complete equation in which there is our reactants and there are products. Next is you need to calculate oxidation number for all the atoms. Just write the oxidation number for all the atoms like I told you when we were attempting a question related to the oxidation number. So likewise just mention the oxidation number. Then just locate the atoms that are undergoing increase or decrease in oxidation number. Pick those atoms or just identify them that whose oxidation number are changing actually, may decrease or may increase. You just need to indicate that. Then calculate the increase or decrease per atom and then multiply it with the number of atoms. Suppose if I have like my oxygen is undergoing a change in the oxidation number by +1, right. So if I have 2 atoms, so I need to multiply that means +1 into 2. So that means you need to see that increase or decrease per atom, and if there are more than one atom you need to multiply the increase or decrease by that number of atoms. Next, now you have the increase also, you have the decrease also, right. So now what you need to do is, you need to balance on both the sides the oxidation number, like the total increase and the total decrease has to be balanced on both the sides by multiplying the factor again. Next, balance all atoms except HNO. Balance everything in the same way as you did for different reactions except H and O. Now to balance O and H is a critical point here. So when you need to balance O, then what you need to do is you need to add H2O molecules to the side which is deficient in O. Suppose if I have 2O here, I have 4O here, so I am going to add the H2O to the side which is deficient, that is here. How much number of H2O you are going to add? The number by which it actually deficient is. Suppose here we have 2, here we have 4, so that means this side is deficient in 2 oxygen atoms, right. So you need to add 2 water molecules here. Now for balancing H is a crucial step because you need to focus that whether the reaction is taking place in an acidic medium or it is taking place in an alkaline medium. So for acidic medium what we are going to do is, we are going to add the H positive ions to the deficient side. Suppose if I have 10H here, I have 11H here, so obviously the difference is for 1H, I am going to add 1H positive here. And if it is occurring in a basic medium, that means an alkaline medium, then what we need to do is, we are going to add, instead of H, we are going to add H2O to the deficient side. Suppose this is my 10H and this is my 11H. The difference is for 1H, I am going to add 1 H2O here. And this, with the same number like I added 1 H2O, I am going to add 1 OH on the side which is rich in the hydrogen. So this is how you are going to do that. So just remember these 3 points, these are very important actually. So for balancing O, you need to add H2O to the deficient side. For balancing H, you need to focus on acidic and the basic medium. For acidic, you need to put H positive on the deficient side, and for the basic, you need to put H2O, which is the deficient side, an equal number of hydroxide ion on the hydrogen rich side. So this is what is the. Now we are taking this question. Just look at the board. So I have this reaction for you, Mg plus HCl, MgCl2 plus H2. So these are my reactants and these are my products. So this is my skeleton equation. Now I need to write the oxidation number for all. So oxidation number for magnesium 0, +1, -1. It is, I can also find it, x minus 2, so it's +2, -1 and 0. Right. So I have written this skeleton equation. I have noted all the oxidation number. Now what I am going to do is, I am going to locate at atoms which are undergoing increase or decrease. So I can see that magnesium, oxidation number of magnesium is increasing. So that means it is undergoing oxidation. And decreasing, whose oxidation number is decreasing actually? H is decreasing. So this is reduction. right. So I have just picked up the oxidation and the reduction. Now what I have to do is, now there is the increase in oxidation number by 2 and here the decrease in oxidation number by 1, right. So now I need to multiply, I just need to you can say balance the oxidation, total increase with the total decrease. So what I am going to do is, this is 2 and this is 1. So that means I am going to multiply the left hand side with 2, because this is 2, this is a going in increase by 2 and this is decreasing by 1. So that means 2 and 1. So I need to multiply 1 with Mg and 2 with HCl. So 1 I don't need to put, so I have put only 2 HCl here. So this is what I have. Now I am going to balance everything except H and O. So this is my Mg1 balanced, Cl2, Cl2 balanced and hydrogen 2 on hydrogen 2. This is by chance that my reaction is ending up at this step, because everything is just balanced. Otherwise, if it is not balanced, we need to focus on these things. Now I will be taking up in another example which will be involving these steps also. So just look at the board carefully.